Today we are gonna go over midterm 1 data structures practice. I haven't studied nor did the questions, so just because I don't have time. So I'm just gonna really do it on the spot. So if I do make mistakes, sorry in advance. Actually, not sorry. You're welcome. Anyways, okay. So we'll head right into it. What is the time complexity of accessing an element in an array by index? So when you have an array like this, and you have like 1, 0, 2, and you tell the computer, I want, let's say this is the name of our array, just array, and you tell it I want 1 at index 1, you are telling the computer exactly where it is in the memory. So it doesn't search anything, it doesn't really do much, it goes straight to the memory and gets it. Therefore, the option would be C here, because, there's no delay, it's constant. Which of the following operations typically takes the longest time in an array list? Accessing an element by index? No, just like we said, that's the fastest one. Appending an element to the end. If the array is like this is vague. Like they should have said appending an element at the end of a fixed size array, or like for example, if I make an array of 10 and I only have 2 numbers and then I add 1 to the end, then I don't have to copy the array and resize it. I can just add it there. So that's why it's a little bit vague. But inserting an element in the middle is usually, because you see in the middle, regardless if it's full or not, you will always have to copy and change it, because assume this is like you have, let's say we're using this array, right? And I want to add 1 right here in the middle. What the computer will have to do, it'll have to copy this whole thing, and then it will have to make another one, add it, add your new element, and then delete this, right? It can't just, like, even if there's like empty spaces here, the computer won't redo, like it won't just shift this to the right once and then put 1 in. It'll just copy and then paste, and so that's probably the slowest one, or takes the longest time. Which of the following best describes a queue? A queue you can always think about like a coffee shop. You have a lineup for coffee, and so the first one in the lineup is usually the first one to leave. Imagine you take a lineup and you're standing there 15 minutes, then somebody who just came leaves. It doesn't make sense. So it's always the first one in, first one out. So that would be A. What is the purpose of a peek method in a stack? Just like it says, it's peek, so it won't remove anything. It will just return the top element without removing it. Add a new element to the top? Nope. So you just basically peek the top element. Which keyword is used to define a class in Java? That would be class. New, you use new to create a new instance of a class. You use public. This one you can create a public variable. You can create a public function, method. But class is definitely the one to create a class. Which data structure is most efficient for implementing an undo operation? So this one, if you want to think about it, like as I'm typing right now, when I do, let's say 1, 2, 3, what the computer has to do, it has to store my most recent one, and then when I undo, it has to undo the most recent one. So the first one in is the last one in is the first one out, right? Because I did this, and then this was my last move, and then when I go back, that is the first one out. So last in, first out. The last in is a stack. So you see when you have plates like this, and let's say this is, so let's say you want to add a new plate, right? So you add it at the top, and then when you want to remove, you remove the one at the top, which is the first one. So last one in, first one out, and that is a stack, since a queue is first in, first out. That means if I wrote 1, 2, 3 and I undo, a queue will remove this, because this was the first one in, so first one out. Therefore, it has to be a stack. An array list, an array list, you remove things by index. You don't really, like I don't choose, remove the third step. Like I remove the most recent one. How do you declare an array of integers in Java? What do we have? Int, that would be this way. This one is to create an integer variable. This one, I don't even think this is the right syntax. Yeah, I'm not sure about this one, but I know it's for sure this one. So you want the type, then you want to tell it it's an array of this type. You want the name, and then you create a new one. Like you have to use the new keyword. What does the remove method of a linked list do? Remove the last element, remove the first element, removes a specific element. You see, in a linked list, when you have a linked list, which is usually you'll have this point somewhere, and then this points to the one in front of it, and this points to the one in front of it. You see, a stack, we said last one in, first one out, so we'll remove this. A queue is first one in, first one out. But a linked list, it doesn't matter. There's no order. That's the whole point of a linked list is just like an array. It's just an efficient type of array. So you just remove which one you want. So that's why that therefore removes a specific element, because you can't just, if you call remove, how is the linked list know what to remove? You know, there's so many nodes. Which of these is not a valid method of initialization? Let's see. List, integer, list, new array list. Yes, array list is actually a Java built-in utility. Linked list is also a Java built-in utility. The syntax looks right. List is a group of utilities, I'm pretty sure, in Java. It is not a type. Like when you say list, what are you talking about? An array list, a linked list, a queue, a stack, a tree, a B tree. So that's why I'm pretty sure it's C. C is wrong, because this is a group of lists, but it's not a single. Like it's not a list. You know, like there's no type of list. It's a group of lists. Anyways, in a doubly linked list, how many pointers does each node have? So remember, single, double. So single only has one pointer. Double has 2 pointers, front and back, from the name. So that would be 2. What is the result of adding an element to a queue that is already full, assuming a fixed size array implementation? What is the result of adding? It throws an exception. It overwrites the last element. It does nothing. So if we're talking about an array list, as in like an array list, the class, it throws an exception. And actually, even when making even a regular array, I'm 100%, 110% sure it will throw an exception. The reason I know this, like I didn't have to research it, but using common sense, if you are working for, let's say, the company that made Java, and you're doing commercial code, you're not gonna write any code without exception. There's no way somebody's gonna tell you, let's say you do system dot out dot print, right? You want to print something to the terminal, and let's say something happens. You don't just not return anything, because then the user will never know there's a problem. So you will always throw an exception, and that's how I know that this will throw an exception, because it's commercial code. Like if it doesn't throw an exception, this will cause problems for just the compiler itself. Like, you know. So which time complexity denotes linear time? That would be O of n. Remember, linear time is like this, straight line. Which of the following operations does a linked list perform more efficiently than an array list? Accessing an element by index. Linked lists don't have indices. Arrays do, but linked lists don't. If you want to know why that is because in a array, when you're making an array, the compiler will go to the RAM, the actual hardware, and it will find a section. Let's say, so we have 1, 2, 3, 4, 5. Let's say you have an array of 5, of size 5, right? Array of size 5. Okay? So what happens is the compiler will go to the actual RAM, it will find 5 empty spaces, right? And it'll be like, okay, we're going to take this, and we're going to book it. Now, nobody can use this space, because it is for this array. And so when you try to access something by index, let's say I say, like the array, give me the one at the first index. What the computer already will do, like, well, I know where this is stored, and I know exactly where it is in memory. So if you're asking for 0, I can go right to the address. But, and this is what makes this very fast. But for a linked list, double or single, and a stack and a queue, when you create a node, right? When you create a node, the computer will store it, let's say here, and then you create another node, right? And the computer will store it, and then just will go find any spot and will store it there. It doesn't have to be one beside the other like an array. An array has to be one beside the other in the RAM, but a linked list or a single linked list or a double linked list doesn't, or a stack or a queue. It just creates the node and stores it somewhere, and then inside the storage, it tells me where the next one is. And so if I'm trying to go to the fifth element, I don't know the address to go to it directly. First, I have to go to the first node, and then go to the second node, and then go to the third node, because that's the only way I know where the next node is. And so now that you know exactly what's happening in the background, you can answer this question, is that which one does the linked list does faster or more efficient? Obviously not index, because there's no indices. Inserting an element in the middle and sorting the elements. Now you see sorting, this one you can right away just take out, because this one obviously depends on the type of sorting you're trying to do. It has nothing to do with the type of linked list it is. It has nothing to do with the type of array it is. It has everything to do with the type of algorithm you're using to sort it. And also the type of data in the list. But inserting an element in the middle, just like we spoke earlier, an array list will, remember, it will book it like this. So when you're trying to insert something in the middle, it will go find another place in the RAM where it has more space, copy whatever is here, take it there, and then insert it in the middle. While a linked list, since it doesn't have that, I can just create a node, put it somewhere in the RAM, and then instead of making this point here, I'll make this point here, and then make this point here. So you see, I don't have to copy anything. I just had to copy this pointer. Sorry, not copy. I just had to change this pointer, and then change the pointer of the new node. And so, therefore, inserting an element in the middle, the linked list is a lot faster. What does the poll method do in a queue? Removes the first element, adds a new element at the end, returns the last element. This one removes, so you see, in a queue, remember, you have first in, first out. So you don't even have access to the last element. Well, obviously it depends on your code, but usually in a queue, you don't even care what the last element is, because you always want to deal with the most recent one. And so this will remove the first element at the top. Now don't get confused between poll and remove. Yeah, so what was I going to say? Poll, so in a queue, so this is specifically for a queue, you have a poll and you have a remove. Okay? When you call this will give you an exception. Okay? So when you're trying to remove something from an empty queue, it will give you an exception, while this one will return null. Okay? So that's literally the only difference. Is that a poll or whatever the fuck that is, it will return you a null. So when you're running your code, it won't break. It will keep running and it will just return null. A remove will return an exception, so it will break your code unless you handle the exception in a try except block. Which I don't think we're doing this midterm, so you don't gotta worry about try and accept, but do know the difference between those just in case. Which of the following is a feature of a singly linked list? Each node has a reference to the next list and the previous. No, that's a double. Each node only has a reference to the next one. Yes, that is correct. Each node has an index property that is false. Remember, linked lists don't have indices. Queues don't have indices. Stacks don't have indices. Only arrays do. True or false? A stack follows the first in, first out principle. A stack follows last in, first out. So remember, a stack is you can think about horizontally, vertically, whatever you enjoy. I don't know why I just made a retarded looking box. Okay, there you go. So you see, let's say like this is your stack, you have blocks one on top of the other, and I add one here. Then when I want to take one, I take the top one. So you see this was the first one in, and this was, wait, did I read that wrong? Yeah, first in, first out. Oh, oops, that is true. Yeah, so you see, this is why you draw. Wait, no, I'm right. Last one, is it last one? Dude, I'm not good at English, that's my problem. This is not the first one in, this is the last one in. Yeah, so last in, first out. So you see, I just added this was the last one I added. And it's the first one out. And so therefore this is false. An array's size can be dynamically changed after it is initialized in Java. An array's size, if you're using an array list, it doesn't say an array list as in the class, okay? Then when you add something, the array list, the class that's built into Java, will automatically resize itself. Now, if you only do like a int and you initialize a little array like this, right? So new array equals new int, and then you give it size 5. This one will not dynamically resize itself. If you want to make it bigger, you'll have to create a for loop, copy everything, and then paste in the new one. So therefore, this is false if this is an array, like a just standard array. If it is an array list, that would be a different story. A doubly linked list has nodes with pointers to both the next and the previous. Yes, it's from the name doubly, and so I believe we just spoke about it. So here this is a single. Yeah, this is a double. It will point to the one before and after, previous and next. So this is true. The size method in an array list returns the number of elements currently in the list. True. Like this is kind of self-explanatory. A queue's remove method removes the last element in the queue. This is false. This will remove the first. Remember, a queue, you always remove the first element. Yeah, because it's a first in, first out. So this is false. Fill in the blanks. Complete the code to initialize an array of size 5. So since this is an integer, this will have to be an int here. You'll write int, and here you'll write 5. Complete the method signature for a Java method that returns an integer. So see, it returns an integer and takes a string as an argument. So here you would type in a string as follows, like string. That's for the argument. And for here, if it's returning, now he didn't mention this. I'm assuming he's talking about just the regular int type in Java, but just pay attention that there's int and there's integer. So int is the built-in data type in Java, but integer is also a built-in class that is of type integer. Okay, so this is a class, this is a data type. So if you're returning a class, it'll have to be an int. Like if you're returning an instance of integer, you'll have to type in integer. And if you're returning just a number, that would be int. Okay, so fill in the missing part of the loop that iterates through an array list. So here you want to do int because I is a number 0. So this is, you'll do int. Here you'll do I. You want I less than the list. So let's do some typing here. So you'll do for int I don't know why it auto capitalizes, but so you'll want int I, and then what you'll want to do is I less than list.size, and so this will exit the for loop once I is less than. Oh, sorry, this will continue the loop while I is less than the list size. So if the size is 10 and I is 0, the loop will go, and then 1, and then 2, and then 3 until I becomes more than list.size, and that will stop the loop because this will return false because I will be more than the list size. And then I++, if you don't put this, remember I is 0, so it'll never increment. So that's why you want I++, so you can increment your I. Yeah, everything else is written out. There's nothing else. Complete the following stack declaration. So since this number is 42, which is an integer, here you can't do an int type. So you can't do an int type. You do an integer type. Okay. So it will be stack integer, and then stack equals new stack, just like that. And then stack dot. Remember, for stack it's push and pop. Pop to remove, and then push to add to the stack, and that would be 42. Just like that. Okay. What else we got? Ordering. Arrange the steps for inserting an element into the stack. Arrange the steps for inserting an element into the stack. Okay, so we're doing inserting. A, return the element. Usually when you insert, we don't return because you know what you're inserting. It doesn't make sense to return what you're inserting. So I'm not sure why that's even an option. Create a new node for the element. Yep, that you will need to do. Set up the top pointer to the node. That one is always the last step. Remember, set the top pointer to the new node is always the last step. The reason for that is because imagine you have, remember, a stack is nodes. So you have this node, and you have another node, and you have another node, and they're stacked one on top of the other, and one points to the other. It's like a singly linked list, but vertical, right? And so the head will point here. This is the head. Now, if I create, let me make this thinner. If I create a new node, right? Let's say this is a new node here. If I create this one, and remember, this is set the top pointer to the new node. So if you set this to this, I lose all that. And so this is always the last step. Push the element onto the stack. You see, this is very vague. Like, what do you mean push? Because usually when you do like dot push, you don't gotta change no header or nothing. Like, does he mean make the node, make this node point to the new node so you can make the header point to it? Like that's so vague. Like, bro, come on. Check if the stack is full. Stacks don't usually have size either, so that's kind of weird. Why you'd check if the stack is full? Yeah, that is weird. But we're just gonna go with whatever he has. So the first thing you want to do always, since there's a check if the stack is full, that is always the first one to do. So E is the first. Then you want to create your new node, right? So first check, is it full? No. Okay, then let's create the new node. You create the new node. Then what you want to do, remember, we said you don't set the top point to the new node. That's like one of the last steps. So I'm going to assume this one is to make the new node be pointed to. So, oops. I'm pretty sure this one is basically to make this node. Here, hold on. Let me clean this up so it's not a mess. So remember, this is what it looks like, right? So before, this was pointing to nothing. Before you make the head point, what you want is you want this to point to the new node, and then you want to get rid of this, and then make this point to it so you don't lose. And so I'm assuming that's what push does, is it makes this pointer happen. And so that's where we're going to put D here, and then we're going to put C, which now you change the head, and the last thing is return the element. Which is kind of why, I don't know why you would, like, if I'm adding the number 42, why do I want to return 42? Like, huh? Anyways, arrange the steps for removing an element from a queue. Remove the front element. Okay, so if you remember, for a queue, it's first in, last out. So let's say all these guys are lined up. They're all pointers. And then when you remove something, you want to remove something from here. Wait, sorry. You want to remove something from here. From the head. Because that's the first one in. So first one in, first one out for a queue. And so remove the front element. Yes. But if I remove this, then I lose everything after it. So let's just wait on removing it. Check if the queue is empty. Yes, you do want to check if the queue is empty, because if the queue is empty, you don't want to do any unnecessary computations, right? So that will probably be the first thing. I'm going to put B as the first thing for now. Check if the queue is empty. Set the front pointer to the next element. Yeah, see? So if you have a front pointer, which is the head, before you make this, before you pop this out, you want to first make this point here before you pop this out. So C, we'll put C after. Return the remove element, that's the last thing. Remove the front element. Yeah, so after we make the front pointer point to the next element, now we can safely remove the front. So then we put A. And then before we return, we gotta decrement the size. So that would be E, then D. Okay, so now we're gonna do the short answer coding questions. The first one is write a method that returns the minimum value in an array of integers. So they give us an array of type int, and we're supposed to return them just the lowest number. And so the first thing you always want to do is your first edge case is what happens when it's empty. Wait, I'm getting a call. I hope this is still recording. Okay, so the first thing is you want to check if the array is empty. So if array equals null, which let's say they don't pass anything, they just call find min, or the array length equals 0, then you just want to return null or return nothing. Ooh. Now the better thing to do is probably throw an exception, but I don't think we went over that, so I'm just gonna leave it as is. Okay, so now what I want to do is initialize an int minimum value, and then make that the array, the first index in the array. Now, they didn't choose a specific algorithm to use for finding the minimum, so I'm gonna use just the simplest algorithm, which is, and the least efficient one is I'm just gonna check every index in the array and then return that. So the first thing I'm gonna do is a for loop, int I equals 0. Okay. Array dot length I plus plus. Okay. So what we're gonna do here is we're gonna initialize I to be 0, and then when I is less than the array length, exit. And then you don't want this as equal because the index starts at 0, so it's not as size. It's less than the size by 1. And then we're gonna increment I for each loop. Now what do we want to do? If the array at whatever index I, so we're gonna start from 0, then 1, then 2, then 3. If that is less than the minimum value, so remember the minimum value is the first value that we're initializing, right? So let's say the first one in the array is 10. So minimum value right now is 10. So the first index I'm going to check is 0, and then I'm going to check the array is what's at position 0. Remember, that's 10. So I'm saying, is 10 less than 10? No. So that actually gives us another idea, is that we don't need to initialize at 0. We can initialize at 1, since the already minimum value is 0. So now let's say at position 1 it's 20. So I'm going to do is 20 less than 10. If not, don't do anything. But what if it was 5? If it is, then now my new minimum value equals that value. Array at I. Oops. Okay. And that's about it. So the loop will keep going, and then at the end of it, I'll just return the minimum value. And that's really all there is to it. I hope that makes sense. If there's anything you guys want me to explain, just comment down below and I'll try my best. Write a method that appends an element to an array list of integers. So public static void append to list array list integer. Okay, so what do we gotta do? Just list dot add value. Remember, for a array list, so if this was a regular array, we would do a completely different method. But remember, this is a class. So for class, there is a dot add, and then whenever you add a new method, if the array size, let's say, is 10, and you're adding the 11th, the dot add will automatically resize the array and then add the new value. So I hope you didn't overcomplicate it. You can do I'm not sure if list.add checks, but in case it doesn't check, you can always do if value equals null, then return just stop. And so you could always do that as well if you want to be extra safe. Write a method that checks if a stack is empty. So public static boolean is empty. Stack integer. So stack dot, oh well, I was just gonna call it as empty, but I guess we're writing that as empty. So what we want to do is just do if, or actually you can just return it one line, but I'm gonna do the long way and the short way. If stack dot size, remember every stack has a size. If the size equals 0, then return true, which is, it is empty. Oops. Else, you don't need an else, you just do return false. So that's one way you could do it. The second way, you can just do return size dot, oh sorry, stack, oops, dot size equals 0. So you see, if the stack dot size is 0, it will return true, and if it's not, this will return false. And so you can do either or. Okay. Okay. So what's the next? Oh, okay. I guess that's it for the short answers. Long answer coding question. Library book checkout system. Okay. So what do I need here? You're implementing a system to manage the checkout of books from a library. Every time a book is checked out, it is placed on the stack. So it says stack of currently checked out books. When a user returns a book, it is taken from the top of the stack. This is a very retarded data structure to use for a book. You'd probably want to do a linked list. The reason being is just because, what do you call it? What if the person returning the book is not the last person that took the book, right? Let's say you take the book, and then I add you to the stack, and then I take a book, and then I add, myself to the stack, and then you return it. You're not at the top of the stack, so that's why I'm like, huh? But let's implement it. I'm gonna remove all this stuff. Actually, before I remove all this stuff, let me see if it compiles. Midterm.java. Let's see. Cannot find simple array list. Yeah, it doesn't recognize that, and that is okay. I just haven't imported it. Cannot find simple stack, which is also okay. I have not imported it. Cannot be converted to int. So you see here, I'm returning null. Instead of null, you can just return nothing. You just end it. Operand types for binary operators. If value, if value equals null. What? Bad operand types for binary operators? I'm not sure what I did wrong here, to be honest, but I'm just gonna go next. Okay, so we're running short on time. We have to import the stack. Okay, and I'm gonna remove all this stuff. There we go. Let's exit this one. Okay, so what do we have? Oops. Let's see. When a user returns a book, it is taken from the top of the stack. Implement a library checkout system class that uses stack to store the ID and provides the following methods. Checkout book int adds a book to the stack. So let's initialize all these methods. Public checkout book adds a book to the stack. I assume you don't return it, you just add it. So checkout book, wait, do they have it? P class checkout, copy code. Oh, okay, nice. I guess I could do that. Oops, what did I just copy? Ooh, what is happening? Is this copying properly? Yeah, nice. Okay, okay. So private stack, so they created a new stack. Public void. I'm confused. Are they using like the built-in stack, or am I supposed to build the stack? The method? I'm confused, but let's see. What is the checkout book? Adds a book to the stack. So if you want to add something to a stack, the first thing you want to do is create the node. And so that's why I'm confused. Like, do they want me to just use the built-in functionality? Like, do I just do put books.push book ID? Like, you could do this and you'd call it a day. I don't know if that's what he's expecting, but I guess I'll just write it from scratch. So, okay, assuming we are making a stack. The first thing you want to do, I'm actually confused. Like, what does this guy want? Private stack. He's initializing a stack. And then he wants to add a book to the stack. You just do like stack.push. Like, you don't really do much. So I'm kind of confused. I'll just do both ways, whatever. Like, so vague, bro. Like, dude, you're talking about code. Who the fuck writes such vague questions like this? Removes the most recently checked out book from the stack. That's top. So you just do like stack.pop. So you do actually return because you have to return an int as it says here. So return stack.pop. Yeah, just that. And I'm pretty sure you're supposed to write them, but it's just like, it doesn't make sense because, like, does that mean that you want me to create a node? Do you want me to like use the built-in stack? Because he's using the built-in stack. So that's why I'm like, what is this guy trying to do? But whatever. P class checkout, you do return stack dot peak. And we're gonna write this, by the way. I'm just using like the short way just in case that's what he wants, because I'm not sure what he wants. So is checkout empty, so you'll just do return stack dot empty. Now obviously this doesn't make sense. Now if we're using this stack right here, I'm pretty sure this would be just fine, but just in case we're not, let's write it from scratch. So checkout book is push one to the top of the stack. So the first thing you want to do is create the new node. So you'll do node, assuming there is a node, you'll do node of type E, which is usually also the type of, unless he has as an integer or whatever. I'm not sure. Yeah, so we'll call this new node equals new node, and then you're going to initialize it with the book ID. Okay? Now, after you've done this, the next thing you want to do is check if the stack is empty. So if stack.size, or assuming I'm within the stack, like, to be honest, I'm so confused what this guy wants me to do. Let's remove these since you guys already know what's going on. Let's put some space here. Okay. Okay. So, assuming, like, I'm gonna have to assume a lot of things here because you didn't really give me much to work with. Assuming there's already a node and there's already a stack, and he wants me to add functionality to the stack, what I'm gonna do is I'm gonna assume the stack is like, I'll have to check it like this. Okay. So if I do stack.size, which is a variable, if that size is 0, then what you want to do, or if book ID equals null, what you want to do is do nothing. That's basically what you want to do. Whoops, what's going on? Okay, return. Make sense? Now, let's take, what if there is, oh wait, you don't want to do nothing. Yeah, if book, I'm tripping out today. If the book is null, you want to do nothing. But if the size is 0, you do want to do something. So if that is null, you don't want to do nothing. And then if it's just because he didn't give me like the actual code to work with. I'm getting fucking confused. But whatever. So what you want to do is first check if the size is 0. If the size is 0, remember, a stack doesn't have a pointer that points to the tail. It only has a head. So what I'll do is stack.head equals the new node. And that is really about it when you have a, what do you call it? When you have an empty stack. You just want to make the head point to it and just return. So we're gonna, do stack, stack.size plus and return, because you're done. If it's not, so usually what you'll want to do is treat it edge case by edge case and then simplify your code. So now this is the first edge case was 0. The second edge case is what if it's not 0, right? So if it's not, we don't have to check if size is not 0, do this. We just write the code, because we're checking if it's 0, do that, and then it returns. So if this is false, it will run whatever under it, and then whatever under it should be the edge case when the size is not 0. Okay? So if the size is not 0, the first thing you want to do, obviously we do have a new node already, but you want the new node dot next to point to the stack.head. Now why is that? Is because the head is the first node. When we're trying to add something in a stack, you add it to the head. You add it on the top, right? First in, first out. If I just make the head point to the new node, you will lose the whole stack. So instead of doing that, what I'm going to do is first make the new node point to the current first node. And then, so here actually, just to make it easier, I'll make 2 nodes. So, and this is, if you do it, I doubt he'll take away marks because this is right code. So this is going to be first node equals this dot, well, it would be stack.head. So this is current first node. Let's do that. Current first node. So, the current first node is the head, or, in other words, the current first node. If the size is 0, what we want is just to make the current first node to be the new node, because there's nothing else to do. But if the stack is not empty, what you want is I want the new node to point to the current first node. Once that's done, then I will make the head point to it. So then I'll do this, or stack.head equals new node dot, well, just new node. And then what you'll want to do is stack dot size plus, and I don't need to return because this is the end anyways. Okay, so that is really about it. Now what you want to do always is, what are repetitive things? So you see this step right here and this step right here is basically the same thing, because the current first node is the stack.head. So actually here, let's remove this just to keep consistency. Current first node, right? Now this and this is the same. The incrementation is also the same. The only difference is I'm making this point to the current first node. Now what if the size is 0 and I do current dot next, which is currently null, I make it point to the current first node, which if the size 0 is also null. So you see that doesn't really do anything different. So if I remove this whole thing, that should still work, right? And it should. And so therefore this is all you need to do for checkout. Now what is the next one? Removes the most recently checked out book from the stack. So you want to remove whatever is at the head. So what you'll want to do is first create the node, and this is going to be node removed node equals stack.head, right? So the first thing is we're just going to store the first node that we're about to remove in a variable called remove node. Now once we've done that, before we actually even do that, we want to check if the stack size is 0. So if the stack.size equals 0, then return null. Or actually, I believe you can just do return -1. The reason we return -1 is because if you return null, it's not an int type. If you just return, you can't do that because you have to return an integer due to this clause right here. And so we're going to return -1, which is usually what like an industry standard of what you return if like you like if there's an error of you doing something and you have to return an integer, usually standard is -1. That's what I was trying to say. Sorry, my English is like lacking, but like it is what it is. So if the size is 0, we do that. Now, if the size is not 0, therefore there is a node, what we'll do is we will take that node, which is whatever the head is at, then we will, before I make the head, so you see, if, what I was trying to say is, if I did this here, which is I do stack dot head, right, equals, removed, or, yeah, removed node dot next, but you see, like, well, one, I'm trying to use remove node before it's even declared. That is problem number 1. Problem number 2, if you did this, which is right syntax, but the wrong goal, I guess, is the right way. If you did this, that's fine. You're making the head point to the next one, but how are you going to return the node you removed? You can't. That's why what I do is first you want to create this variable, then I want the stack.head to equals the removed node next, whatever is after the removed node, point there. Now after I've done that, since I just removed it, I'll do stack.size minus minus, then I want to return the removed node.value or .data, whatever the fuck he wants to use, but I'll just use value, which should be an integer. Okay, so that is really about it. I'm trying to remember if I forgot any edge cases. That should be about it. But anyways, like I said, I haven't studied for this, so if I'm doing something wrong, don't blame me. I'm just trying to help. P class checked out. Oh, so peek the top basically. Remove the book ID from the last checked out book without removing it. So what you want to do is if stack.size equals 0 again, you want to return -1, and then what you want to do is this dot, well, would be stack dot head dot value. That's what you're trying to return. You're not trying to really remove it or anything, so we'll just return that stack dot head dot value, which is the first one. This one is the easiest one. Is checkout empty? So you're trying to check if the stack is empty. All you gotta do is return stack dot size equals 0. If the stack equals 0, it will return true, therefore it's empty. If the stack size is not 0, it will return false, therefore is not empty. Hopefully I didn't butcher that. So that's an extra one, I think. Okay, yeah, and that is about it for this midterm practice. If you guys do have any questions or if I didn't make any mistakes, please do make a comment down below and I will make sure to fix it, or if you have a question, I will try my best to answer. That's about it. Hope you guys do well, and have a good night.